Let's take a look at another type of infinite limit problem, one where we are actually given the limits and the limit behavior and asked to graph the function instead of given the graph and asked to find the limits from the graph. So sort of making sure that we are able to go both directions and truly understand what limits mean and now what infinite limits mean. So if we have a list of criteria, and we have quite a bit of criteria here, this says graph a function that satisfies the following. And we're given some information. In the first line here, we're given some information about function values. And then in the next 3 lines, we're given some information about limits of the function and what the function is doing around certain x values. X equals 3, x equals 2, x equals 0, and x equals 4. So let's go ahead and get right into it. There's no restrictions given here on the domain, and so we'll go ahead and graph a function that's going to satisfy all of these given conditions. So there's lots of ways to start. I drew in a little grid over here for us to start working on, but I like to identify where we've got some interesting behavior, some points, anything I can kind of get just to get started. So like f of 1 equals 0. Looking at that first piece there, I can quickly graph that. So let's go ahead, give ourselves some scale here. I'm looking at that actually, and I want to go a little bigger on my scale. I just realized that I could go a little larger so that we have plenty of space on the screen. Okay. So if f of 1 is 0, I'm going to go ahead and plot that point right there. So f of 1 is 0. F of 3 is undefined. So I'm not going to cross that off with my highlighter yet. I'm just sort of going to underline it and keep that in mind. F of 3 is undefined. So the function itself doesn't have a value. It doesn't have an output value, a y value at 3. But we might have some more information that we're going to use as we go along. So we'll kind of keep that in mind. And then I'm just going to keep working my way down. And we'll look at that. The limit of f of x as x approaches 3, let's look at these two together now, is going to approach 1. So let's make this 1 to make the scale the same. And at 3, f of x is going to approach 1. Now, I have to put an open circle there. I'm going to make it really exaggerated right here for the screen. I have to put an open circle right there. I don't necessarily know what's happening further on, by 2 or 4 until I get further into the rest of my criteria that are given. But I do know, and so I think I'll just draw it in red on here, I do know that from both sides the function is going to be approaching that value 1, but it's not filled in because the function itself is undefined there. So we have a limit, the function from both the left and the right, because it's a non-directional limit. The function is going to be approaching 1, but it is not defined. f of 3 is not defined. It's undefined. So I'm just going to put that in red right there. This is why it's really good to work with pencil or something that you're able to erase and adjust as you do math, because those are just sort of my notations to myself. I'm going to keep going, and then when I get all done, I'll use black to really mark in where my function is. So I'm going to keep going. We've sketched in that criteria, and I'm going to keep going here. So now what is the limit of the function as x approaches 2? So let's highlight what we're working on now. So notice, again, it's a non-directional, meaning it's going to be happening from both sides, and the function has an infinite limit, and it's increasing without bound. So the function is actually approaching infinity from both sides of 2, which means any kind of infinite behavior means I actually have a vertical asymptote. So let's sketch in a vertical asymptote at 2. And it's from both sides, it's going to be going to positive infinity. So again, I'm just using my red here, giving myself some guidelines. And again, I will connect all my pieces, because right now it kind of looks like a mess. It's just a bunch of little arrows on my graph, but I'm going to connect all my pieces when I get done. I just want to get all of my guidelines in before I connect the pieces. Okay, so from both sides of 2, the function is approaching positive infinity, growing without bound. So let's take a look at the next criteria that's listed. The limit of the function as x not equals 1, that should actually be an arrow. Tried to set that up ahead of time. As x approaches 1, 0. The function is going to be decreasing without bound. That's what it means when it says negative infinity. So as x is approaching 0, and it's not directional, so that means from both sides of 0, the function is going to be decreasing without bound, approaching negative infinity. Well, once again, that creates a vertical asymptote because of the infinite behavior. So for this function, we'll have a vertical asymptote at 0. And we're decreasing without bound. So again, my guidelines, I just put in my little arrows as guidelines. So I have a vertical asymptote there, and from both sides, the function is going to decrease without bound. All right, let's keep going. The next piece of criteria I'm given says the limit of the function as x approaches 4 from the left. This one is a directional limit. So 4 from the left is going to increase without bound. But that creates another vertical asymptote. This function's got all kinds of vertical asymptotes and infinite behavior. So we have another vertical asymptote. Coming from the left of 4, we're going to approach or grow without bound, approach infinity. Now coming on the other side of it, the very next criteria tells me what happens on the other side coming from the right. We're going to decrease without bound. So we're going to decrease without bound. So coming from the right, we're going to be decreasing without bound. And so what I have right now is I have a bunch of criteria sketched in. I have to create a function. What I have here in red are really the bones or the guidelines for my function. I am now going to create a function that satisfies all that criteria and is a function. And it is important to remember that a function that we're looking at, f of x, is a function. And a function must pass the vertical line test. So a function, every x value has a unique output value, a unique y value. So we have to remember, in order to be a function, we must pass the vertical line tests. It's a little subtlety that sometimes gets forgotten as we're putting together a function with a bunch of different criteria, that we're not looking at 5 different individual functions. We're looking at one function, and it's all going to have to meet this criteria. So it must also pass that vertical line test. That's a little pre-calculus concept coming up there, that we truly understand what it means to be a function. Okay, so I'm going to come in here. The function that I draw might not be the function that you draw. In fact, there are an infinite number of functions that would satisfy all these pieces of criteria. And so that's why it's sort of like a choose your own function. It still has to meet the criteria, but what we do in order, how we create the function in order to meet that criteria really is, some individual choice. So for instance, I'm going to go ahead and draw a function that looks something like this, and I'm going to flatten it out right here and actually give it what we call a horizontal asymptote. Your function doesn't necessarily have to do that. You could squiggle it off out towards the left side of the graph. Then I'm going to create a function that comes up. It does have to pass through that point. We made that point in black. Has to pass through that point. F of 1 has to be equal to 0. Then I'm going to shoot it up along this vertical asymptote. As I go, I think I'm going to, I'm going to clean up some of my little red guidelines as I go here. I erased half my graph when I did that, but there we go. And then I'm going to create a function like this, and like this, and like this. And now, this black graph that I have here, y equals f of x, meets all the criteria. And it is a function. It would pass the vertical line test. So we have a function that meets the criteria. Now, again, as I said, your graph might look a little different. Like, let's just suppose, for instance, I were to, I could absolutely make it, do something like that if I wanted to. It's still meeting the criteria. I just added a little flair there at the end. Okay. One last piece before we finish this example. Let's go ahead and just state, since this goes along with our section on infinite limits, let's go ahead and just state the vertical asymptotes of f of x. So we actually have 3 vertical asymptotes on this graph, 3 different places where we have infinite behavior on this function. where the function is either growing or decreasing without bound around vertical lines. So x equals 0 would be our first one, x equals 2 would be our second, and x equals 4 would be our third vertical asymptote. And there we go. We had a choose your own function where we're given a bunch of criteria and we create a graph to satisfy that criteria. And we're also able to pull off what the vertical asymptotes are after we're done.